people have probably called them like region allocators. Like there's lots of different names for it.
Arena sounds so badass, though. I can see why it's like the term is starting to stick.
I have a more flexible JSON-like format that I designed that I have a parser for, but JSON's a subset of that
Of
format.
course you
so I'll
did.
just
Wait, you made your own. I need a soundbite of you saying something like, Malloc is too high level for me. Welcome back to Backend Banter. Today I'm joined by Ryan. I've only seen your last name typed. Is it Fleury?
Yeah, that's perfect. Yep.
Ryan Fleury, you're joining us. You're a game developer currently working at...
I work at Epic Games. I work on sort of the sub-team of Epic Games that used to be Rad Game Tools before they were purchased by Epic. I came into programming because I was interested in making games, and throughout my time programming games, I kind of got more and more mad at tools that I was using. So I started with engines. A lot of people start bottom up. They kind of are like, they just love computers, they're writing assembly on day one or something like that. I mean, you see more of that like 30 years ago, but...
I was going to say, I don't see a lot of that anymore, but I'm sure it happens.
Yeah, but you can think of a conversation with a senior where it's like, oh, I started reading the 6502 manual or something like that, and that's probably not even right. I'm not familiar with that world. So a lot of people are bottom up. I'm more top down. I started with engines, stripped them away when I got fed up with them, and eventually I got down to the point of like, I got really into working on more tooling and engine stuff, so I started going a little bit lower, and now I work on the Rad Debugger project, which is, I mean, just developer tooling. It's just a native graphical debugger for user space code. That's what I do. I work on primarily tooling. I still have my pet game projects, but that's not what I do, like, for the most part.
Awesome. We met on Twitter. You slid into my replies when I was talking with TJ about his memory management course, and you brought up arenas, which is great because, frankly, so basically TJ and I collaborated on this course. He wrote it. I helped produce it. It's on the boot dev site. It's, learn memory management in C, and you build your own garbage collector. And we talk about memory management. I mean, I don't want to make it sound like it's not modern because, I mean, it is new, it is up to date, but we talk about memory management from the perspective of, hey, let's build a ref count garbage collector. Let's build a mark and sweep garbage collector. Let's show you how this stuff works in memory. And you were like, you should talk about arenas. And I was like, I don't know about arenas. So I brought you on to talk about arenas.
Awesome. Well, yeah, thank you so much for having me. I'm glad to be here.
Yeah, I'm super excited for this. So to give everyone just a really quick understanding of arenas, can you do a quick compare and contrast from like arenas, manual memory management, and maybe like the traditional way we think about garbage collectors, just so everybody's on the same page?
I think the first thing I would say is that arena is a very overloaded term. So a lot of people mean a lot of different things by it. My personal, my usage of the term comes from sort of more it's some category, some subset of game developers use it in a very particular way. Other people use it in a different way. Other people use other words for what I mean. With that caveat in place, the way to think about arenas is that they're just like the stack, basically. So when you first learn Z programming, you learn about like pushing variables onto the stack, right? You learn, if I say int x inside of the body of a function, that's going to be allocated. I mean, these days, obviously, it's going to be allocated into a register and all these things. But you're thinking conceptually of the stack and how if you call into a function, pushes onto the stack, once that function exits, you pop back out of that function. So the arena is just taking that stack-like allocation pattern and applying it to a larger category of lifetimes than your call stack at any one point in time. The basic principle behind this is that the stack sort of organizes lifetimes together, right? So if you push a bunch of things onto one in the body of one function, once that function exits, all of those things are jettisoned completely. You're not supposed to, for example, return pointers to things that were in that function's local variables. That end of the function sort of marks the end of an overarching lifetime for each one of those variables. You could almost think of that as some like proto version of a garbage collector, if you wanted to stretch the definition a lot more. And I think that people sort of inherently feel that because when they're working with things on the stack in C, it's generally not super difficult at the beginning. When you're first like learning, okay, put a local variable onto the stack, have an array, have a counter through the array, these kinds of things, all in local variables. It's not complicated. You don't have to clean anything up. You don't really have to do anything. You just have to remember the simple rule to not like return pointers to anything to outer scopes. Then the thing that comes in is sort of the traditional C style manual memory management, which is like malloc and free generally is what people will be taught, which is like arbitrary heap allocator. Every single dynamic allocation is one new lifetime that you've added into the mix. And that lifetime, if you don't want it to persist forever, needs to be terminated at some point at the appropriate time. And that's when you sort of return it to the global malloc allocator. Arenas are just saying, hey, this like stack style allocation scheme is pretty useful for functions. We can't use it for everything because oftentimes the lifetimes of things we want to allocate conflict with our functions. Like if we want to allocate something deep in a call stack, the second we exit that frame, that thing will be freed. We won't be able to allocate long lasting things that way.
Can I ask a question about that really quick?
Yes.
So
yes.
It's really interesting to me that before even going to malloc and free, which for anyone that hasn't taken the memory management course, by the way, this conversation is going to make a lot more sense after you've taken that course. So just so you know, I'll try to like introduce a lot of these concepts, but if you're totally lost, you might want to check that out. The stack is where local variables within a function live during the function's execution. And like you said, you create a variable local to a function, x equals 5. When the function returns, that variable's memory is automatically cleaned up by the stack pointer. You don't have to worry about that. So when we talk about manual memory management, we're usually not talking about that. We're talking about the malloc and free portion that you talked about afterwards, as opposed to stack. That's heap allocations. And if I'm understanding what you're saying correctly, that's basically when you need the memory to span outside of the lifetime of the function. And the last bit that you said there that was really interesting to me was like, okay, arenas are kind of like the stack pointer when it comes to functions. You're like, I'm imagining the scope of the function as essentially a little mini arena. And it is weird to me that functions in production code, or I guess in any code, doesn't matter whether it's running in production or not, are kind of ways to organize our code. Like they're almost organizational tools more than anything else. They're not memory management tools typically. I don't usually think of a function as a memory management tool. And if what I'm hearing you say correctly, or maybe this is just what I'm making up, it's like we could have arenas that aren't necessarily tightly coupled to the scope of a function, but that work in a similar way to automatically clean up memory. Is that kind of what an arena is?
Yeah, I would say that that's like a pretty good like angle on it. So one of the things you'll see people recommend when people are doing C programming is like to avoid this problem of functions implicitly calling malloc, for example, unbeknownst to the caller of that function. To sort of combat that problem, one thing that people will often suggest is like the caller should allocate and then pass a buffer to the function that they're calling. And then it's the function implementation's job to fill out that buffer, but it's not supposed to allocate anything. It's supposed to use whatever the caller passed to it. That is like not a bad idea. In fact, in one sense, it's what people do with arenas, but it's a little bit hairier than that because the function that you call may want to be closely involved with how that structure is allocated. So if it's just a single buffer and you know how big it needs to be and things like that, then it's not that big of a deal. Like the caller can allocate the buffer, pass it to the function can fill it out. But let's say that it's not a buffer and it's like some variable number of nodes because you're parsing a stream of text or something like that. Like you have this big stream of JSON, you're parsing it, but has to be relatively generic parser. You have to build out the whole tree structure. The parser is the one who figures out how many nodes it needs to allocate. It's not the caller who's going to know that. I mean, you could have like, right, okay, I'll fail once you get past this certain point or something like that, but it's not an arbitrarily good solution. It breaks down fairly quickly is I guess what I'm saying. With an arena, it's kind of like saying the thing that the caller passes in directly to the function is a handle to here is a backing store for all of the allocations I would like you to do, but I control the lifetime of that. So I'm saying, okay, I have a big block of text, parse a JSON tree out of it, put every single one of the allocations, just push it onto this arena. And the user tells that function which arena to put it on. And so now you kind of get the best of both worlds because the arena, as I kind of use them, it can either have a large reservation of address space and the ability to grow, or it can grow through chaining. Either way, it's not a fixed upper limit. The stack, for example, one problem is that you run out of space on the stack, right? Stack Overflow, yeah, everyone knows Stack Overflow. An arena, because it's not defined in like sort of the way that the operating system will set up your thread stack or something like that, Instead, you can kind of control. It's like, okay, if I'm running out of space, what am I going to do? I could get into virtual memory stuff because that's one very useful way you can actually do it. But you could also, for example, allocate a new block and start pushing onto that block. The blocks are discontiguous, but you can still keep pushing onto the arena.
So it's like the block, the memory exists in different address spaces, but it's all kind of one arena virtually.
Yes, yeah. You can think of it as several arenas chained together if you want to think.
Okay.
It depends on how you slice it. Like, is one arena one contiguous block? I don't know. But generally, I refer to the arena as the entire chain of blocks. Point being, that JSON parsing problem. You pass it the arena, and now the parser gets to decide how much it allocates and when it allocates. You don't need an initial loop which scans and needs to determine how many things to allocate or something like that. Instead, the parser can actually just allocate whenever it wants, but it's only pushing onto a buffer that the caller has prepared for it. Effectively.
So in that scenario, does the caller have to know pretty intimately how the called function is going to use the memory? Like, it has to pre-allocate you said that the call E, so the function being called could expand the arena if need be. I guess what I'm asking is, how much work does the function that's passing the arena into the other function, how much work does it have to do to know that it's passing the right amount of arena?
Yeah, so basically none. Like, that's kind of the magic part about it, is that the caller prepares the arena, which is just this very simple allocation.
So it could be like arena.new, and that's basically all it needs to do.
Yeah, pretty much. That's how I do it, literally. I mean, the caller can specify, whoever is creating the arena has the opportunity to specify certain constraints on the arena. Like, at the very first line of your program, you could say, all of my memory is going to be in this single arena, and it's going to be, I will disallow chain growth. Like, I won't allow this arena to grow. I will allocate 8 gigabytes up front, and it has to fit in that. If not, abort, like, not going to work. Similarly, that code path could also just say, I'm creating an arena. It's going to start with a 64 megabyte block. If I run out of space on that 64 megabyte block, I'll chain on new blocks to it. Or another growth strategy would be, I'm going to reserve 256 gigabytes of address space. But that's not a physical commit of memory. That's saying, here is this address. I'm reserving this address space so nobody else can refer to these addresses legally except for me. But there's no physical memory backing those pages yet. And then when I'm pushing onto the arena, I run out of the space I've committed so far. So the part of the arena that has actual physical storage. When you're about to end that region of the arena, that's when you can call back down to the operating system and say, okay, please guarantee physical storage will be there for this new range of addresses within this large block of reserved address space. So the caller gets to decide things like that, so very high-level things about the way that the arena is able to grow. But then when you actually pass it down into the JSON parsing helper function, that function can just push, and that's all really that it needs to do. Now, if you could imagine a more complicated function would actually be wanting to temporarily free things, it can still do all those things on the arena. It just only needs to push when it actually knows it needs more actual space from the arena, if that makes sense. We can unpack that a little bit, because that went over a lot of details. So
okay, so in the example that we're using here, it sounds like we have, let's just say, a kind of a main function, and it's the caller, and it's going to allocate an arena. Let's just pretend that we have like an arena.new method that returns like an arena object. I don't know if that's quite the right word, but let's just pretend that it is for a minute. And then we've got like this parse JSON function as input. Maybe it takes the arena itself and a stream of data, and its job is to like read from that stream of data and allocate kind of structured JSON into the arena. So it's reading from the stream, allocating into the arena, and the whole point is that like the caller main is the one that created the arena, but now this function that needs to do dynamic allocations has a place to do them. Maybe we'll get to this later. In theory, like later in main, we could do some sort of like arena.cleanup or arena.free. Is that kind of what we're talking about here?
That's basically how I would describe it. And it's not structured in exactly the way that I use it, but it doesn't matter. Point is, when you begin the arena, you're sort of establishing a lifetime, like formally as this structure that you're using. And then when you pass it to the JSON parsing function, yeah, exactly. You're saying, if you do a dynamic allocation, I mean, this is assuming a JSON function that's like built in this style kind of thing. But yeah, you're basically saying to the JSON parser, push all of your results onto this arena. So now I know as the caller, every amount of memory that you've allocated that hasn't been cleaned up by the time you've exited is now sort of stored on that arena as a lifetime. This is related to other, many new languages have explicit allocator passing. So they'll say something like, pass me an allocator and I will use that to allocate explicitly, like Zig does this, for example. The difference with the arena is that it's simpler than that. It's not doing a generic allocator interface. So the interface of the arena is push and pop. It's not malloc and free, where you can have arbitrary overlapping lifetimes inside of the arena by default, and they can all intermix. Like you could malloc A, malloc B, malloc C, and then free A, free B, free C. That's not a support. At the base level of using the arena, you can only push new bytes off the end and then pop them off the back. So it's very simple. It's much simpler than...
And do you usually pop like that, or do you usually just free the whole arena at once?
It kind of depends. Like I said, arena is sort of like, it's this handle that refers to a lifetime of memory. It can be applied to a lot of different cases. So one example is like, if you're writing a game, you might have a per frame arena. So every frame you clear the arena, meaning you reset the allocation pointer back to, the 0 position or whatever the minimum is. And then you push and push and push. You can put like strings on there. You can put all kinds of random dynamic stuff that you're allocating on there. And then at the beginning of the next frame, it's sort of garbage collected and the pointers reset again. So you could have that as one overarching lifetime. Another pattern that comes up would be like if you're running a web server or something like that, you could have like a per request arena. Some request comes in, you're about to prepare a bunch of results. I don't write web servers, but I know vaguely how they work, but you have a bunch of, you have some inputs to the request, you have some work to do per that request, you have a bunch of results to respond with. And that arena could begin at the beginning of the request. You push all the results onto it in linear fashion, so it's just like the stack. Once that data has been presumably like sent over the network or something like that, then you can clear that arena. That memory is available for use again. Now, there's a different pattern you could do, which does actually work hand in hand with like sort of the call stack kind of model. So with the traditional C model, like we talked about before, there's a fixed block of memory called the stack for every thread that's in your program. And when you allocate some variables and, fudging the register stuff away from, many of them are being allocated in registers, but once you run out of registers, then they'll be pushed onto the stack, or in debug builds, they'll always be on the stack. Whatever. Point being, you have stuff on the stack, memory that's being used for these variables. It's less of this like allocate a bunch of stuff and then reset everything. It's more like several granular versions of that, right? With functions, because it's like, okay, allocate a bunch of local variables, call into a function, allocate a bunch of local variables, pop back to the point you were when you began that second function, and so on and so forth. So you could use arenas like that too. And that's how they come in handy with a different case of using arenas. So one example would be if I am in a function where I would like to put things onto the lifetime of my current function scope, I can't use the stack, right? If I've written all this code about arenas, like I have a JSON parsing helper library inside my code base, that code is all written to take an arena. I can't pass the stack as an arena. Like I can't really do that. Because that's automatically being managed by the generated instructions by the compiler. But I need some way to expose my sort of scope lifetime to this function. And so what you can say also is that you just have like per thread scratch arenas, which are kind of like stacks that you've kind of prepared for each thread. You can just pass that as well, and then you can begin the lifetime at the beginning of your function, pop it at the end, and then anything in between is just whatever allocations you want to do during the lifetime of that function. You can also get an arena for that, is my point. And so that's more of the push and pop style.
Got it. Okay, here's a point that I just want to emphasize and make sure we don't gloss over. Because I said earlier, and I probably was not precise enough when I said this, that like, okay, the stack's great because it's kind of automatically scopes to a function. And you don't have to do quote unquote manual memory management for like, x equals 5 within your function will automatically get popped at the end. But the other problem with the stack, it's not just that it's like bound to functions. You could almost argue that's sort of an implementation detail. It's more that like, it's not dynamically allocated. If I'm being fed data across the network, I'm not stack allocating. I can't stack allocate that data. I have to dynamically keep asking for more memory from the operating system. So to be clear, and correct me if I'm wrong, like arenas, they work in a similar fashion to the stack in that it's push and pop, and it's kind of automatically adding things into the arena and taking it off the arena, cleaning up the arena. But it is possible to dynamically allocate it as opposed to the stack?
You can actually use the stack for some dynamic allocation things. In C, there are functions you can call like alloc, for example, which will push a variable amount of data onto the stack.
Oh, okay.
Someone, I'm sure, will correct me if I'm wrong, but I'm fairly certain there's a way to, at least it varies by operating system, because the operating system is the one doing the allocation. Like, that's another thing, is that there's no true dichotomy between stack and heap allocation. The stack is just one dynamic allocation that the operating system has done for you before it called you, right? It's saying like, okay, you're spawning a thread, I've allocated a stack for that thread, and I've set up the registers for the stack pointer, okay, go. I'm pretty sure on Windows, perhaps, I don't use this, I just kind of use the default stack as it is, but I'm pretty sure on Windows and probably Linux, I'd be shocked if not, that you can say, I would like a reserve and commit style like allocation here. So I want my stack to be 1 gigabyte, but I don't want to allocate actually 1 gigabyte of memory up front. I want to do incremental committing of physical memory too. Basically, as I push enough onto the stack, only allocate the pages when I actually touch those. In fact, that's probably what's going to happen by default. On Windows, those semantics are a little bit more explicit, so I might be remembering a specific compiler flag to do that kind of pattern. But that is actually the thing. Like, the stack and heap, they are terms that sort of exist at a semantic layer, but there's no difference between stack memory and heap memory.
They're it's still RAM underneath the hood.
Yeah. Both are ultimately virtual address space reservations from the operating system. Both are going to have all the same caveats. It's just that one is sort of being micromanaged by the compiler, by the compiler's generated instructions. It's doing all the stack work, and the operating system is micromanaging, like, what that allocation looks like and how big it is and things like that. Although you can tweak it. But yeah.
So I do a lot of Go programming. My mental model of stack and heap is pretty simplistic for the most part. It's like, I'm pretty aware of when things are going on the stack, and I'm pretty aware of when they're going on the heap, but I don't have to do much other than that. It's funny, because anytime you say anything in programming, like you can do X or you can't do Y, usually not actually true. There's like crazy ways to get around it, or if there's some architecture for which it's not true. But just to follow up on that, so you mentioned dynamically allocating on the stack is a thing that you can do potentially. Is that common? Like, or is it just like you could do it, but like...
Yeah, usually, I mean, some people will do it. Usually not, because I think people are... In the code that I read, I almost never see it done, because it's like, people are kind of paranoid about how much space the stack has on it. And rightfully so. It's like, the top level code is going to be deciding how big your stack is. If you're writing a library, for example, you don't want this to be dependent on, okay, this library works, but only if you haven't, like, called it 20 call frames deep or something like that. Like, that's not generally how you want to write libraries or something. And so if you're about to do like a alloc call, and you're like, okay, allocate 64 kilobytes or whatever, it's like, okay, goodbye stack. Like, you just can't do that. And so it has fairly limited utility unless you're really controlling the whole thing. It also has limited utility for that coupling reason, where it's coupled to which functions you're calling. I can't use alloc in C to return something to my caller, because the second I pop out of that function and go back to my caller, that allocation is now, it's freed, right?
It's still a local dynamic allocation, right?
But it's that memory is no longer legally accessible by the caller after that function is popped. Right. So it's like, you can't... It has more limited utility. The difference with arenas is that you can separate the lifetime from the actual function lifetime. Yeah. So I could say, okay, begin a scratch arena scope, call into this JSON function thing, look through the parsed tree after the parse has come back, and then pop. So I can kind of expand the scope outside of what the function would have allowed me to do.
It's not tightly coupled to function call and function return, even though it's like at the, not the hardware level, that's the wrong term, at like the conceptual memory management level, it's kind of similar to a stack, but it's decoupled from how your code is organized, it sounds like.
Yeah. And so I guess what I would say is that we covered a lot of details there, and people who maybe aren't familiar with like the concept might be kind of going like, okay, like, and so what?
Yeah.
And the reason why is because once you have these lifetimes established, so once you've sort of organized these things, which is a very small task relatively, like I gave some real examples, like, one arena for every frame in your game, you begin an arena scope, and you clear it at the beginning of every frame, off you go. The benefit to all of this is that it's virtually, you don't have to think about freeing anything. Like, it just becomes a non-issue. It's like, I've okay, I'm going to allocate a string, like a dynamic string variable length, could be any size for all I care, it doesn't matter. I don't have to think about that. I don't have to call malloc, which means I don't have to call free. I've pushed it onto the arena. The arena's already set up by code I wrote several months ago, and so I'm done, basically. All I do is push, and then I forget about it.
I'm just waiting for you to say zero cost abstraction.
Well, I wouldn't go that far, but I will say, so in the game development world, I'm not sure how common it is with like back-end web stuff, but in the game development world, there's like a common thing that people say, which is like, don't dynamically allocate in a hot loop. Like if you're doing a bunch of hot like work that needs to be very tightly scoped, it's supposed to run extremely fast. You don't want to be you don't want to insert a malloc call in there or something like that, because malloc's implementation has to be fairly complicated because it's doing a fully generic lifetime management problem. Because any allocation you allocate, there's no guarantee, like with the arena, that it's in some order. There's no stack-like pattern to it. Anything you allocate could be freed at any time. It has to manage all these structures in order to...
So there's like a lot of logic there that potentially has to run.
And there's also like concerns about... I mean, the newer malloc implementations are generally smarter about this part, but there are also concerns about like, is this going to cause interlocking with other threads while I'm calling it in this hot loop? Like there's... like the older malloc implementations definitely had problems with that. Newer ones, I think, have been smarter about that problem. But point being, you're not supposed to dynamically allocate in the hot loop. That's like the slogan, I guess. With an arena, what's a dynamic allocation? Well, it's like the arena has been dynamically allocated. If I'm allocating, what do? I take a pointer from the arena and then I add some number of bytes to the arena's pointer in the common case, right? If it has to grow, that's a genuine cost, but you can tweak the arena such that you don't have to grow in common cases. In the common case, your allocations can be as simple as remember this pointer, like return that as my result or whatever, and then add some number of bytes to the arena's allocation pointer. It's just like the stack.
So yeah, I was gonna say in the common case, it sounds like basically a stack allocation.
Yep. So it's just as fast, just as simple. That like bit of wisdom kind of just goes away. Like you just have this very simplified allocator and you push onto it and you forget about the allocations and they're cleaned up for you later. So it's once you've kind of gone this route, what I found when I kind of learned about these and started really using them, all of the traditional concerns about memory management in C went away. Like it was not a problem for me anymore to manage mallocs and frees. I didn't have problems with memory leaks. I didn't have problems really with like use after free or things like that. It became much simpler to think about where my memory was going, having it cleaned up appropriately and things like that. So I think the problem just gets a lot easier and you just you just don't have to think about it very much anymore. And I think it's very useful to people.
So I have one question about, I know I'm just like re-explaining the concept 1,000 times, but I think it'll be helpful to the listeners.
Yeah.
I've got one more question about explaining it, and then I have a maybe more interesting question.
Okay.
So the first one is, are you familiar with slices in Go?
I mean, I know the word slices in other contexts.
Okay.
I'm assuming it's like, okay, yeah, go.
I'll just give it like a brief overview. I'm sure there's a lot of people listening that probably don't know too much about them either. Basically, a slice in Go is just a view into an array, right?
Okay.
So arrays are fixed size in Go, just like in C. So you can have this array that's like, 1,000, has 1,000 entries in it, an array of 1,000 integers. A slice would be like a view into that array. So maybe from, index 0 to index 8 is your current slice. The interesting thing about Go is that we basically never use arrays directly. When you use slices, they just allocate arrays in the background. And when you create a slice, kind of the normal way to do it, if you're not being like too precise about performance, is you just create like an empty slice and then you'd push onto it with like the append function. And in the background, it just grows. So like maybe the backing array starts at like 8 entries. And once you push past 8, it reallocates a new array of 16 entries, copies the old data from the first array to the new array. This growing sort of happens in the background. You've got the length of the slice, which is actually how many items are in it. And then you've got the capacity, which is the size of the backing array. And I guess my question is that basically arenas like, but for memory?
Yeah. So I would say that that's exactly it. It's just that same concept with a caveat, but it's basically the same concept except applied to raw memory in general. So it's taking that pattern and instead of saying we can only use this for this particular array, you're applying it to the concept of memory as it's used by anyone anywhere, basically. So like I said with that JSON parsing example, how that function has to be aware of how it's going to be allocating, how many things it's going to be allocating, in what order, like when it finds them during the parse phase or whatever. It's not necessarily allocating one type of thing. Like JSON nodes, I mean, the way I would write it, JSON node would be a singular type, but a lot of people don't do that with JSON. And, partly for good reason, because the grammar doesn't work that way, right? You have like differently typed nodes. It's a heterogeneous sort of abstract syntax tree. And so you have certain, like you have an object node and an array node, and I guess a map would be an object. I'm trying to think. You probably have different nodes for like numeric, like entities, I guess, or numeric literals and string literals and things like that. Those are probably all differently typed nodes. Similarly, you might want to be dynamically allocating strings, for example, if you're doing processing on strings from the original text buffer, something like that. Yeah, the arena is sort of at a lower level than what you're describing with slices, so that you can intermix these allocations. It's so you can say like, okay, allocate a node, and I want to generate the string for this node. Let me apply some processing to the input text stream, and that's the string for this node. And so push that onto the arena, that goes there. Okay, I'm parsing an array of numbers, right? So I'm allocating the node for the array of integers, and now I'm descending one level into the parse and finding all of the integers that are in this array. Okay, allocate all these nodes, or some structure, probably not like a linked list or whatever, but like, probably just a bunch of these chunks of numbers that you're parsing out or something. All of these like heterogeneous allocations are all going onto that same like quote unquote slice. So that's the main difference. Now I think there was another point that I thought you were going to with the slices thing, which is pretty interesting, which is, so the way that I understand the word slice is slightly different from what I think you explained, which is that the slice is kind of like it's sort of like the read-only view into the buffer. That's how I think about it, where it's like, this is actually probably the same distinction as like in C++, you have std string, you also have std string view. The string view thing is what I think of as a slice.
Got it.
But it sounds like Go kind of welds those two concepts together a little bit.
Yeah, I mean, like you can change what's in a slice. Like you
Right.
can swap out elements and stuff. It is,
Okay.
it depends on exactly what you mean by read-only. Like if swapping out elements isn't allowed in C, that is allowed in Go, I guess.
Yeah. Like, for example, when I think of the canonical example of slices, at least with the way that I write code, is with string, like length strings, basically. So if I have a string, it could be the JSON text buffer, actually, and I'm trying to like pull a sub-region of that string out and point at it and say, like, this is the string attached to this node or something like that. Generally, what I do is all of my strings are slices, and so I'll say, okay, I'm going to form a new string slice, basically, and the base pointer of that is going to be the same region of memory as the initial string. It'll just be offset. I'll say like, okay, refer into the original buffer. So I've got the overall buffer.
It's like multiple slices into the same backing array.
Yeah, and you treat all those as immutable is the important part. So you kind of like, you don't mutate through those because they're all pointing at the same thing. And so you have a kind of an immutability by default kind of rule.
So like you can do that in Go, but like the slices in Go are just like you use them the exact same way you use like lists in Python. It's just kind of like the default way to do ordered collections.
Dynamic arrays or stuff like that.
Yeah,
got
exactly.
it. Okay.
Or vectors in C++, right?
Yeah.
Very similar, not like similar implementation, but like you use them in a similar way that you probably would.
Yeah. Okay. Other caveat that's pretty important, difference between like slices and arenas, other than being like sort of byte-based, like generic memory allocating kind of thing. When a slice resizes in Go, I would assume that you cannot assume the pointers remain stable. So if you have a pointer to an element in a slice, and that slice resizes, it's not guaranteed that pointer is still valid.
I believe that's correct. I believe it gets copied to a new address.
Yeah. std vector, I think every implementation works the same way, where it'll do a realloc, which is basically like check the initial allocation. If it's not big enough, double the size or something. I don't think it's literally double, but you expand the capacity somehow, reserve a new block, copy the entire array to that new block, and then you're done. But that invalidates all your pointers. With an arena, the way that I write them at least, I don't do that. That's why I do the chaining or the large virtual address space reservation and incremental physical commits of physical memory. Because after a resize, so after you chain a new block on, or after you commit new physical memory to back your virtual address space reservation, those pointers all remain stable. So you can take pointers to them before, after the growth, doesn't matter. Everything's in the same region. So that's like one pretty important difference. It simplifies a lot if you can assume pointer stability. So that's why I say that's important.
So during the lifetime of the arena, as long as you haven't like popped, the memory addresses are stable.
Yeah, the addresses are stable no matter what, but yeah, I mean, if you pop, the problem with popping is that somebody else could push and overwrite what you were pointing to. So it's the same thing as the stack, right? It's like, once you pop out of a function, you had some variable. The second you exit that function, that variable's memory is still going to be there. It'll have the same value in it. But then the problem is that you could call another function, and that function's going to stop on that memory, right? So
the chaining of the arenas doesn't screw up the memory address space of the previous arenas. Got it.
Exactly. Yeah, because it's a linked list of large fixed size.
Linked list basically being doing the heavy lifting, right? Because you didn't have to copy all that memory to a new place, which is how slices work with backing arrays. Okay, very cool. All right, this leads me to my next question, which has frankly been in the back of my mind ever since you responded on Twitter, which is, I've heard hearsay of arenas for a while. Haven't dug super far into them. What people are hearing here on this podcast is basically my understanding of arenas. They sound like this kind of too good to be true zero cost abstraction. Like I create an arena, I magically put stuff into the arena, later I free the arena, I don't need a garbage collector anymore. If it's all so true, where are they? Like, why aren't we using them all over the place?
The reason why I brought up the name thing first, the fact that people refer to them by different names, I think that's important for understanding the answer to this question. So the first thing I would say is that people have been using these for before I was born. Yes, the stack is an arena, but even before saying that, game developers have been using arena allocators like forever. And they go by other names too. So linear allocator, bump allocator. People have probably called them like region allocators. Like there's
arena
lots of different names.
Sounds so badass though. I can see why it's like the term is starting to stick.
Yeah, I mean, what can you do? I agree with you. So people have been using this for a very, very long time. I think the problem is that the knowledge of how to work with these allocators effectively, in many cases, it doesn't escape like certain teams, for example. And so the place where I learned about them was watching Casey Muratori on Handmade Hero. This was his thing. He's like, I don't need a garbage collector. I don't even need RAII. I'm not doing any of that. I'm just doing very simple allocation schemes with like these very basic allocators. In fact, the first thing in Handmade Hero that he does, or one of the first things he does, is at the beginning of his program, he reserves a block of memory for every single allocation his program does. So he knows whether or not his allocations are going to fail by like the fifth line of the program. Like there's no more any allocations after that, other than, he calls into OpenGL or in Handmade Hero, it was OpenGL. I'm sure the user mode driver is doing tons of stuff, but point being, he's not allocating more stuff after that.
Right.
When I learned about them, I was watching him, and I felt exactly the same way as you described. It's like, wow, this sounds really way too good to be true. How is it so easy for him? Maybe he's just done a lot of practice or something like that. And I mean, everything requires practice, but I think the reason why I had never been exposed to that before is that Casey was he worked at Rad Game Tools, and that they were kind of this old school game development industry kinds of low-level C kind of programmers, and they'd found ways to work comfortably inside of C. The ways that they worked comfortably inside of C didn't involve, like, a lot of people like to say, like, skill issues, just write better C or whatever. Like, there's lots of, like, that kind of discourse. That's not, to be very, very clear, that's not what I mean. I'm not saying that. They found ways to be comfortable in C because they simplified their problems. And so when he kind of showed how you do that, that was like light switch for me. It's like, oh, now I get it. Like, now I see how you can change the definition of your problem to make your allocation patterns very simple, and off you go. And the reason why people probably don't talk about it very much is because it's like, once you see it, it's actually very trivial. It's like, oh, it's a stack. That's it. And I just have multiple of them now, instead of just the one, for local variables or whatever. It's like, no, I have a level stack and, so on and so forth. And so I think it's a very simple idea, but I think the reason why I've talked about them a lot and why Casey talked about them in Handmade Hero probably has to do with the fact that there's so much unlearning to do. Like, people have to unwind a lot of this stuff about how complicated memory management is, because that's what people say. Looking back at it, it's like, doesn't have to be that way. It can be a lot simpler.
Within the context of C programming, it's not like a special library that you import to do arenas. Maybe there's some libraries, I don't know. But like, I'm assuming that's not what we're talking about here. It's a way of writing code. It's a way of architecting and thinking about your program. And you kind of do it up front. and you need to like build your whole program in this style. And so if I'm understanding what you're saying is it's basically like you just need to get out of the mindset of using malloc and free in the way you've probably been taught.
In principle, there's nothing really wrong with malloc and free. Like, it's not that malloc and free should be deleted or something. It's that they're just introducing a lot more stuff than you need for most problems. Most problems can be simplified in this kind of like stack-like allocator way. With malloc and free, it's like you're doing this whole generic allocation problem for every like little micro allocation you're doing. But a really sensible way to use malloc and free is to implement an arena with them. So you can say like, oh, malloc 64 megs, that's my first chunk in my arena.
Because like you are using malloc and free, you're just like doing it in chunks, basically, right?
I personally don't use malloc and free, but you can use them for arenas. Because
how do you do it?
I program primarily on Windows. That's where the game development industry tends to work.
It's unfortunate, but here we are. Yeah.
Yes. I mean, what can you do? I mean, I like my audio drivers working. Unfortunately, I won't get. People are going to yell at me in the comments. If I
no, I have a PC and a Mac, and I've been thinking about switching to PC and Linux. But like, I can't get away from PC because it's where I play games. But I despise doing any work on it.
Yeah. That's just I don't know. That's various reasons. I think one important thing is that Windows tends to have the best debuggers for game developers. For the kinds of work that game developers are doing, debuggers are very useful. On Linux, you're stuck with like GDB and LLDB, and people don't tend to like those very much. So on Windows, I'm less familiar with the Linux picture, but I know it's slightly different. Things are coupled a little bit more. But on Windows, malloc is a helper function implemented inside of the C runtime library, and it is itself calling into the operating system for you. The operating system provides a much lower level mechanism for doing memory allocation, which is called virtual alloc. And virtual alloc is like the API that Microsoft wants you to call when you're doing like the lowest possible level like memory reservation kinds of things. And that's how you can do some of those like virtual memory things I was talking about. So
you call that?
I call that, and I just implement all the higher level stuff on top. That's what malloc does too. Like malloc has to call virtual alloc. In fact, I think malloc technically calls heap alloc, which is a higher level helper that Microsoft wrote as well. So malloc calls heap alloc. I would assume that Microsoft's C runtime library calls Microsoft's heap alloc function. I hope that's a safe assumption. Maybe they duplicated it.
I need a soundbite of you saying something like, malloc is too high level for me.
Yeah, well, oh man. I mean, there'd be too much to unpack, I guess.
Sorry, I cut you off to make a stupid joke. Keep going.
No, you're good. Yeah, so I just call virtual alloc, and then I just build these arenas with virtual alloc. Because virtual alloc, it's not like a generic heap allocator like malloc. Like with malloc, you could do something like allocate 8 bytes, for example. Like you'd say like, okay, I want 8 bytes, or I want 100 bytes, I want 256 bytes, and I'm mallocing that. With virtual alloc, you're talking to the operating system's page allocator. So it's doing the job of passing out ranges of pages inside of your address space to processes. So it's basically saying like, I've reserved, page, n, wherever n happens to be, like this address, and then the minimum granularity that you're going to see is 4K. So it's basically like at 4K granularity, that's what virtual alloc is doing.
So it hands you a whole chunk, deal with it, whereas malloc gives you a little finer grained API to deal with the individual bytes that you need and stuff.
Right. Yeah, exactly. So malloc is built to be some ways more generic, in some ways less generic. It's more generic in the sense that it's like more size variable. Like it's not for these giant chunk allocations. It's for many micro allocations. It's less generic in the sense that it doesn't expose like virtual memory semantics, which are universal on consumer hardware and server hardware, for example. I just build the arenas with the virtual alloc API because it's like, it provides me extra functionality. There's fewer intermediate layers. There is overhead, but there's no extra overhead incurred by a malloc implementation, basically. I just like to do it at that layer. But you could use malloc and free to build an arena. There's nothing stopping you from doing that. So I think it's really a pattern thing. It's like, are you calling malloc 10 million times or 10 times in your program? Like, that's kind of the problem I'm getting at. It's been helpful for me to think about how to get it down to 10 rather than just like going off to infinity and trying really hard and then having mallocs all over the place and like, oh, I'm pointing to that, but I freed that, and I freed that, but it was already freed, or I allocated that and I never freed it, so now I have this leak. It's like, none of that has to happen. Just a better way of using malloc works.
Okay, here's my next question then. And it's kind of along the same lines of like, why don't we use arenas everywhere? Sorry to use another Go analogy, but it's where I do all my work. So
You're good.
and it'll be helpful to our audience too, because we got a lot of Go developers listening. Okay, in Go, there's this concept of the context. It's part of the Go standard library. And basically the context is this thing. You can imagine it as just an object, kind of like an arena, that you pass around your various function calls in a web server. The most useful thing about the context is that it can be canceled. So for example, if client makes an HTTP request and while the HTTP request is being processed, say a database call gets kicked off, the client disconnects, that context is canceled and the server can abort early, essentially, that call to the database. So it can like clean up the function really quickly and efficiently because the context has been canceled. Contexts are really cool. Thing is, anytime you're making a function call in Go now, because context pattern is so ubiquitous, you basically need to include this in your function signature, this additional context parameter. Just kind of by convention, it should always be the first thing that you pass to the function. So for example, instead of like db.getUser pass in an ID, it's something like db.getUser context ID. You pass them both in. Now, I'm not saying that it's bad, but I am saying that like if you have a code base that hasn't been using context and now you need to introduce context, you've got to change all the function signatures. And it's like very at the application layer, you're very aware of it. And I'm sure there's some programmers out there that are just like, can't this thing like be invisible in the background and not like bother me all the time? Is that what it's like working with arenas?
I think what you said is accurate. Like if you are coming into a code base that hasn't used arenas, it's going to be a pretty large task to like move all of the code to being arena based. And yes, as you're writing code, you definitely do have to be aware of like what arena you're pushing things onto. To me, that's acceptable. To a lot of people, it's not. I think the wins outweigh the costs because the garbage collector, obviously, it has to basically infer what you're manually doing with an arena. So the arena is saying, I won't access this pointer with this allocation after this lifetime ends, and you specify that by which arena you pick at what point in time. A garbage collector also has to like figure out when you're going to stop accessing something, but it has to fish that out more implicitly from all of your code. There's a lot of problems with that. You do pay the cost of saying like, okay, I've got to specify this arena manually, but the win, obviously, allocations become very fast. Frees become trivially fast, and I don't have to think about freeing. To me, that's a worthwhile trade-off, but you're right. Yeah. It's a little bit of extra friction at every kind of function call kind of boundary. For every function call, that does dynamic allocation.
Yeah, it like takes an allocator. And yeah, I'm not like saying that it's not worth it. In fact, arenas, especially based on our discussion today, I'd need to do a whole bunch more research, but like they sound awesome. And when you described a web server as like, I can imagine like a function handler that handles like an HTTP request having its own top level arena that you can do all these dynamic allocations in that just automatically gets cleaned up. That'd be hugely efficient. Cause like in Go, like we build these highly performant servers that handle thousands of requests per second, but like you still have that GC loop that just happens every once in a while, right? And so memory builds in this sawtooth pattern. If you were able to do a lot of the allocations that are happening on the heap within an arena, I could imagine that having huge performance boosts.
Yeah.
To web servers in particular. Okay, so like in C, if you want arenas, you build your own arena. we got that, right? Like you're building an arena.
I will throw in there. Like I said, they're so simple, which is kind of why nobody talks about them. And that shows up in the implementation. Like if you try to build your own malloc, you can build a simple malloc in very little code. But if you're building like a production ready malloc kind of implementation, I mean, you can go look at them. Like me malloc is available. I think JE malloc, or there's a few different malloc implementations that you can import and use in your C code base like today. And they're pretty, I don't want to say big because it's not big in the grand scheme of things, but it's like several thousands of lines of code because they have all of these like fairly sophisticated tracking data structures and things like this because they're solving a generic problem. So it's going to be harder. With the arena, it's like 200 lines of code at most. Like the one that we use on the debugger project, it's in alpha still, but it's been running on this arena implementation for a very, very long time. It's something like 200 lines of code. Like it's not much code. So you can do it very easily, is my point.
Are you aware of any languages or tool chains? You mentioned Zig does something similar. Then you made it sound like it doesn't actually do arenas. Are there any languages that are building support for arenas like directly into the language, or at least into the conventions that you're aware of?
Not really. I think, yeah, like Odin and Zig do the most. Like Odin has an arena implementation. As far as I know, Gingerbill, I mean, I don't want to speak for him, but he has said before, he's like, I use arenas in the same way you do, but he didn't quite go as far as standardizing their practice in the way that he and I use them throughout all of the Odin standard library and things like that, because it's just, it is an extra step to learn for people, and he wanted to make it more like, he uses that kind of generic allocator interface that Zig also uses, because it's more familiar to people who are used to working with a malloc and free style.
Is that
like,
more
interface.
similar to malloc and free? Like just,
yeah,
allocate
like
a thing. Okay.
That's like kind of the standard interface that Odin has, and it also has a thing called a context, but I think it's different. But that context is passing through that allocator implicitly, and that allocator is a generic allocator, so it's not an arena. It could be an arena, and Zig does the same thing, but that's not quite the same as standardizing. Zig standardizes on explicit allocators, which is like halfway there. The problem is that the arena helps simplify both implementation code and usage code, and so by requiring everyone to conform to the generic memory allocator interface, nobody can really be guaranteed that they don't have to call free, for example. They still have to go and do all that work, even if the free is actually a no-op, because you're secretly passing an arena. I've not seen any language do this kind of thing in a first-class way. Lots of code bases do it, but yeah, no languages to my knowledge.
Fundamentally, it's just to have the right interface, it's a different interface, right?
Yeah. It might not be totally true that nobody is like standardizing on it, because I'm sure garbage collector implementations, in fact, I'm 99, without having looked at them, I'm like 99% sure that production garbage collector interfaces are doing arena-like patterns all the time. They're just doing it implicitly. So they're not doing it all the time, obviously, because you could have longer lasting allocations that break the lifetime patterns of any individual arena. I think they'll move the allocation, like they'll assume if it's a short-lived allocation or something, they'll assume it's on a short-lived arena scope, and then they'll move the allocation if it's not, that kind of thing. So there's some stuff like that. You could argue that it's being used in standardized garbage collector implementations, but not in the same way that I use them in C, where it's like explicit, but just kind of like first class everywhere kind of thing.
Okay, now I'm going to try to get you to play devil's advocate and like tell me, all right, so you use arenas, but like, wink, when do you stop? Like, do you ever escape hatch and just like malloc and free some stuff?
I never escape hatch. I will sometimes call a library which escape hatches.
But it's like you're forced to at that point because the library does it.
Yeah, like you could, like STB image is a good example. You can change the allocator that it's using, but if you don't change it, it's going to call malloc. And so I just kind of live with that. I could go so far as to like sneak in an arena somehow. Through their malloc and free, like
just on principle.
Yeah, just on principle, exactly. You do get some wins for that. Like you could see it if you have debug visualizations in your code base of like seeing when memory is allocated and how much memory is allocated across time. There's some use to that. It's mostly on principle, but there's some win you get for it. But
yeah.
I never personally go to malloc really. I will just build more complicated allocating structures on top of an arena lifetime. And so this is the whole other half of like working with arenas that generally people get hung up on. A lot of people will say, these arenas sound great, but like, what if I do want to free something out of the middle of the arena? Like it's a game level and an entity is destroyed or something. I can't like pop it because it's in the middle of the arena. I can't like, there's all this stuff allocated after that entity. How can I pop back to the middle?
The problem with stacks is they're fast because they don't let you do shit.
Yes, exactly. And so the way you solve that generally is you implement the higher level allocating structures yourself on top of, so basically you still have the arena lifetime and you still have that allocation in the middle and it's still allocated. You can't free it. But what you do is you build your own free list on top of it. Let's say it is entities in a game level. Every entity is larger than 8 bytes, presumably, is big enough to store like a pointer to a next thing in a chain. And so what you can do with that is if an entity is released, you can just say there's a pointer at the beginning of every single entity. If that's too costly, you can just use it when they're freed. The point is when an entity is like destroyed and you want to reallocate it for some future entity, all you do is you move that to what is generally called a free list. So this is basically a linked list of things that are free to allocate within like a pool of memory, for example. You can think of like, you have like a big array of entities, and if these 3 are free, you can imagine some pointer, which is the top of the free list, pointing to the first one that's free. This one points to this one, which is free. this one points to this one, which is free. Everything else is not free, so you can't allocate it because it's being used by entities that are alive or whatever. That's the first example of a more complicated allocation structure that you build on top of an arena, where it's this. Go ahead.
No, I just want to make sure I'm understanding the purpose of that. So is it that the next time you push onto the heap, instead of going to like the end, it's going to go fill in one of those gaps?
Right. So instead of having to say like push a new entity onto the end of the arena, you still have some free ones that are left over that were from entities that got blown up or whatever. And so you can just pop them off the free list, and now that's a live entity again. And that entity is now like the new entity that spawned somewhere else, for example. So you just reuse that slot. And this is what malloc implementations do. This is what
I was going to say. This is kind of funny because like now we're full circle. Like we just built malloc in free, right? Kind of.
Yes. Like when you take this problem to the extreme, you're absolutely right. Like you end up at malloc in free. They solved exactly this problem for the generic problem. The difference really is that you're not solving generic problems. You're solving your problems. And so a single free list is also like an extra 5 lines of code or something. Like it's not hard to implement a single free list between fixed size things in a pool, for example.
Yeah.
And so once you have that's like first thing, then you can start ramping up the difficulty. You could say, now I don't have fixed size things that I want to, kind of release and free. Now I have strings. You can have variable length allocations. As you layer on more and more constraints, it becomes more and more malloc-like. My personal experience is I never really get to that malloc level. Like it never has to become that generic. Do you have to do some more complicated allocation things? Yes. Are they ever as complicated as malloc and free? No, not really. Is I guess what I would say. I mean, that's not true for all problems, obviously. I'm talking about like what I tend to work on and the problems that I see. I don't tend to ever need that complicated of an allocator. Obviously, if people are really pushing the boundary, they will want a very fast allocator. And yeah, at that point, you would not do yourself a disservice by grabbing memalloc, for example, and using it, which has very good performance, for example. And it also still has a many of these like newer malloc libraries. They're not just global, which has a lot of problems. Like many of the problems in malloc and free are that they're a global allocator, and so you can get like a scoped allocation. Instead of passing in an arena, you pass in a heap, and that's now your handle to the whole malloc allocator structure. If you need general purpose allocation, use general purpose allocation. But my experience is that usually you don't.
Now I need to go read up on... I saw news a while back that like the Go team was considering arenas, and I have no idea how true that is. But I'm curious because like I'm imagining what it could look like, and I could imagine there being some sort of like essentially arena object that's context-like that you pass around and use, and it's this interface with like push pop and free or whatever, but that you don't use it all the time. Like because obviously Go by default is just like, we'll do heap allocations and get garbage collected. But like when you're trying to be, like you said, in like the 90% or the 95% of cases, like you can get all these kind of performance benefits by, explicitly going into an arena.
Yeah. With something like Go, I would imagine that it would make more sense for either explicitly the performance case like you're talking about, or as an optimization to certain garbage collector patterns. I would be surprised if they hadn't done that already for the garbage collector, but yeah, I mean, there is a performance win. In C, it's simultaneously a simplicity win and a performance win. So your allocation problems get simpler in C when you do it. If you're in a garbage collected language and you're kind of not thinking about allocations anyways.
Yeah, your code's already simple, even though it's magically being slow. Yeah,
right. It's like not thinking about this problem at all. So you're not going to feel like it's simpler at first. The actual code that's being executed is probably going to be simpler. Like what the CPU has to do is going to be simpler, but maybe you feel like there's this new burden on top of it. So
I like that you say maybe you feel like there definitely is a burden on the application developer. It's not made up. I mean, you still have to write more code. Yeah, CPUs don't have feelings.
Yeah. That's definitely fair. My feeling on it is, I would rather spend a little bit more effort at the beginning of a project than getting to the end and noticing that the garbage collector is too slow and being like, well, I gotta write arenas everywhere, I guess. Like start really trying to put things into pools and just avoid the garbage collector at all costs. I know that happens a lot with like Unity games, for example. Like a lot of people have given talks and talked about how when it came time to ship, they're like, man, this garbage collector is killing us. Like this is not playable. And so
Yeah.
What do? It's like, all right, it's time to go re-architect a bunch of stuff. And that's a painful process. And so that's my trade-off. I get it, though. I have a higher tolerance for that kind of thing, I would assume. So
I love having these conversations because game developers, web developers, like, we're developers, but we work in very different worlds in my experience. Game developers are much more tolerant of Windows, for example. Game developers typically have to think a lot more about performance. Sometimes, as web developers, we like to tell ourselves that's not true. There definitely are web developers out there that have to think really, really hard about performance, but it's usually different. Like, it's not graphics programming, for example. Mm-hmm. And so I guess all this to say, like, it can be really hard to start a project, say, with an engine that uses a garbage collector, get to the end of the project and realize that essentially your dependency, the garbage collector, is the thing that's making you slow. And so these days you prefer to kind of build bottom up. Totally get that. In the web development world, I would argue because so many projects, you understand the scale of the piece of the web system that you're building, the risk of that happening is lower. It still can happen. Famously, Discord got all sad because their Go servers were too slow and they decided to build them in Rust. I'm still skeptical of all the details of that story. But I guess my point is, like, there's different trade-offs when starting a project, and it's just a different world. I don't know.
Yeah, definitely. I mean, I like having these conversations too, because there's a lot of unfortunate discourse, which, on both sides, to be clear, which tends to, like, minimize the problems that the others are facing. Like, oh, that's web development, like, that's not real. Or, oh, that's game development, that's very specific, that's not real, like, that's not what we have to deal with, kind of thing. The reality is that we're both using computers. We do have different problems. So it's not true that we're solving the same problems, but a lot of things in computing are pretty generalizable. You know, I think it's worthwhile to kind of have people from different kind of sub-industries to talk about stuff like this, because it's like, we're all programming computers, techniques that work in one field, they probably don't just work there, actually. They probably can be applied elsewhere. And I think I really like the opportunity to talk about this stuff, because I feel like there's probably a lot of insight to be gained just from people from different sub-industries talking to each other, because I think sometimes they don't tend to talk to each other. And so it's like, oh, weird, you guys do you guys do this thing in game development, like, way different than we do over here. And it's like, yeah, it works great, try it out. And I'm sure there's parallels for web developers to the game development world too. So
there are people rolling, like, you know, pretty crazy custom web stuff. I don't want to say those people don't exist. One thing that I think is so cool about game development is that there's people like you that are like, no, actually, you know what? I don't want to start with an engine. Like, I'm going to build from the bottom up. You know what? I don't want an engine. You know what else I don't want? I don't want to use this really high level function called malloc. Like, I'd prefer to stay away from that. Instead, I'm going to build my own little arena allocation system. And to your point, like, you know, you've kept it simple and it works. And I'm not saying that's bad or wrong. It's just fascinating to me because it's so different. Like, no Go programmer building a web server that I'm ever aware of has been like, you know what, this garbage collector thing, like, I'm just going to allocate like an array of fixed bytes and like, we're going to roll that to get this web server working. So it's like, there's different conventions and mindsets and just, it's almost like cultural norms about like how you would start a project.
Yeah, for sure. I think there's probably some degree of historical accident too. Like, the introduction of an arena allocator to solve an allocation problem makes more sense in C. If you're just sitting there thinking about the problem, it makes more sense there than it does in a higher level language that has all of this memory management machinery built in. To that point, there's tons of libraries, tons of stuff that's been built for web development for languages other than C. So it's probably no coincidence that those libraries exist there and people aren't thinking about like C-like problems there as well. So
I don't know of anyone writing like a custom web server in C. Does anyone do that?
I mean, arguably, this is maybe not what you would call custom anymore, but Nginx was all C, I think. But
I guess that's what I'm saying is like, that's like an off-the-shelf, like, you know, load balancer and file server.
Right.
I mean, like, you know, my company's JSON API. Like, I don't know anyone building that in
probably
in C.
And I'm not sure that there's like, I hate saying this because I get very frustrated with website performance, but they probably don't have any reason to. Like, there's probably good reasons for people to be doing what they're doing. And as much as I want to, like, yell at everyone and be like, oh, just do it better kind of thing, it's like, well, change the incentives and you change the outcomes kind of thing. Yeah, I mean, I build some web stuff in C, but it's not really a server. Like, I basically, it's more client-side stuff where I'm doing... I don't write my own, like, definitely not, like, the security layer stuff. And I don't have my own, like, HTTP parser after the security layer stuff. But I do write web stuff for managing, like, I have a Discord server, and I have, like, Stripe subscriptions, and I also have a Substack. And I have to synchronize the state across all of those places. Like, if I want subscribers on Substack who've subscribed via the Stripe payment backend, and if I want to somehow correlate those with Discord usernames and also my private, I don't know how to pronounce it, Gitty, whatever.
Yeah, Gittia. I don't know.
Who knows?
I say Gittia. I don't know if it's right.
I've kind of been hoping I've just not had to pronounce it. I just read it and write it, and I'm good with that. But yeah, here I am. So I run one instance of that, and I want people who subscribe on the Substack, for example, to get access to both Discord stuff and also the Gittia stuff. And so I just write web stuff to, like, synchronize all of those things in C. But that's a simple problem. That's not like a web server kind of thing.
Do Stripe and Discord have SDKs in C, or did you have to roll your own?
No, I just call the HTTP APIs myself.
Got it.
Yeah. So I don't have, I guess I'm not sure exactly what people do. Like, I don't know if SDKs are just calling the HTTP APIs under the hood. I haven't done this stuff much, so.
Yeah, they are under the hood. It's just nice because, like, for example, you're in a statically typed language like Go. If you're using the official SDK, you get, like, autocomplete of the available function calls and stuff like that.
Right. Yeah, that makes sense.
But yeah, it's just using their HTTP API under the hood, I'm pretty sure.
Right. Okay.
Unless they've done, like, some advanced RPC stuff that's hidden or something. I don't know. Probably
okay. Yeah. Yeah, that makes sense. Yeah, I tend to do basically that. Like, I'll do the HTTP stuff myself, and then it's not technically a JSON parser. I have a more flexible JSON-like format that I designed that I have a parser for, but JSON's a subset of that format. Of course you did. So I'll just...
Wait, you made your own...
Yeah, I mean, I could deep dive on that, but long story short, it's basically a more flexible JSON. It's to me, it's more comfortable for handwriting. The reason why I initially made it was not for data transfer like JSON. It was for very comfortable handwriting for the purpose of metaprogramming in C, and so that's why it's called Metadesk. The point is, JSON is a syntactic subset of this Metadesk format, and so I have a parser for Metadesk. And so I can plug JSON from these HTTP requests into it and get my parse tree out, and then I just use the Metadesk trees. That's, like, a pretty comfortable way for me. In fact, I wrote the same thing in Go first. I'm not much of a Go programmer, but I was like, I assumed I'm doing web stuff. Better use the language that people use for web stuff. I know I was doing Gittia API stuff. I could use the Gittia code base as a reference. I didn't end up doing that. I just ended up doing it in Go for basically no reason. I mean, it was fun. Like, I got to learn a little bit of Go, but my C version is shorter, actually. So, like, I wrote the Go code, and I was like, maybe it was bad Go. Like, so, I don't want to say, like, oh, C is better than Go for this or whatever, because I don't know. I could have just done a really crappy job of doing Go. But I wrote the Go version, and I was like, I really just want this in my own code base. All of my code is in C. I have arenas there, for example, and I just wanted to do stuff that way. And so I just ported it to C. It was not a particularly long program, like it was 1,000 lines or something like that. Yeah, the C version was like 200 lines shorter, and I'm like, okay, great. Like, and now it's in a language I'm comfortable with. So
was it because Go Thumped added new lines? That's that is interesting because Go, like, obviously Go is written by C people. I can't think of why it would be longer because you just strip out the allocations and it should look pretty similar, but. I don't know. Yeah, I mean, even though I'm using system libraries for HTTP requests, but anytime I do that, anytime I'm talking to, in this case, I'm on Windows because game developers use Windows. I'm using WinHTTP. But anytime I rely on a system like that, I always wrap it in my own abstraction, and I do that so that I kind of control the abstraction. I control the code that's written to the abstraction. I don't couple my code with a particular system's interface too much. I do the same thing. Yeah.
Yeah. I like to do that. What I'll try to do is, if I'm writing to, for example, WinHTTP in this case, I'll try to investigate alternatives on other platforms. So I have some model in my head of how this abstraction has to look. And then I'll build a first pass of it and then and then start looping on it. But yeah, so I'm writing to WinHTTP and I built my own abstraction, and I noticed that just the HTTP abstraction for me felt I wasn't super familiar with the Go language semantics of like I don't know, you have a string, but that needs to be converted into a stream reader, which I don't know. Don't ask me about Go stuff. But point being, it was like I kind of designed it to be a little bit more fluid for my code base in C. I'm sure Go people are like, this guy's an idiot. He could have just done X, Y, and Z or whatever.
There may have been some standard library things to use.
Yeah.
Maybe.
Yeah. And I did that. Like, I would follow online resources and stuff to try to do this stuff. And they're like, oh, you need like, man, I wish I could remember more specific details. But yeah, I mean, I don't know. And it ended up being simpler, but that's probably mostly a familiarity kind of thing, just because it's in my code base. And I write all my game stuff in this code base, and now I wrote this web thing in this code base. So it was like, it's just a lot more familiar to me.
Well, this has been awesome. Thanks so much for coming on, man. I had a blast. I knew vanishingly little about arenas, and now I know a little bit more about arenas.
Yeah. Oh, go ahead. Sorry.
No, I was just going to say, like, I want you to plug your stuff, like your Substack. Let people know where they can find everything else that you've published, so they can read more if they're interested.
If people are interested in sort of a concrete code base that uses arenas, so if they want to say, like, if they kind of understand the point and they're like, I want to go see how these things are working in practice, you can check out the project I work on full-time professionally, which is the Rad Debugger. It's on GitHub. It's just an open source project completely. It's all MIT licensed. So people can check that out.
We'll drop links to all these places. Yeah.
That code base is something like 150,000 lines of C. That's all built in this style. So you can go see, like, how do they do string stuff? Like, how do they allocate for this particular kind of problem? And it's a full graphical application written that way. So you can go look at it if you want. And then apart from that, I've written one fairly popular blog post on arenas, which tried to do my best job at introducing the topic at the time. And then I also gave one talk on it. So, and those are both on my Substack, which are at rfleury.com, which is rfleury.com. And then aside from all the arena stuff, there's tons of other adjacent topics that I write about, stuff that I pick up as I work on the debugger and some of my other projects. I'll pull out lessons and try to package them up. I did a whole series on UI programming, for example, because I wrote all the UI for the debugger. So that's what I've got to plug, basically. Oh yeah, and I guess Twitter or X, it's Ryan J. Fleury. So it's Ryan and then J and then Fleury.
Amazing. Go check out Ryan. Again, thanks so much for coming on, man. We'll talk to you later.
Yeah, thank you so much, man. Appreciate it.